Imagine you have a 4K monitor connected to HDMI cable. The 4K monitor has more than 8 million pixels. Each pixel is just like a tiny light bulb. They turn on and off to create the image. Even if you multiplex in them, you still need 6,000 wires to control them. But the HDMI cable has only 19 wires. So how is it possible to take control more than 8 million light bulbs just by using 19 wires? They use something called shift register. I'm using this IC to explain how it works. I have 8 LEDs in here and I can control them through 4 wires only by using these 3 switches. So let's say I want to turn on the first LED, the last LED, and one LED in the middle. First I have to flip this switch and set it on 1. Then I push next. The second LED must be off, so I flip the switch to 0 and push next. The third LED is also off, so I push next. The fourth LED is on, so I flip the switch to 1 and push next. I repeat the same thing for other LEDs. When I'm done, I push display. So as you can see, the same pattern transferred to the LEDs. You can cascade this circuit and add more LEDs, as many as you want, and you still need only 4 wires. The name of these switches in the datasheet are different. The next button called the clock, the on-off switch called data, and display called latch. The project that I'm planning to make is an LED matrix with 64 LEDs, and a switch matrix to turn on and off each LED separately. In normal situation, you need 65 wires to connect them together, but I'm gonna do that by using only 5 wires. I used a shift register for the x-axis, and a counter IC to switch each row. For the switch matrix, both ICs are counter. They scan the switches one by another, and if any switch was closed, the current through this resistor creates voltage, so it activates the output of this op-amp. I used a 5-volt voltage regulator because this is a TTL IC and it cannot work with more than 5 volt. I designed the PCB and ordered it from a company called Next PCB. Upload the Gerber file here, you can find it below in the description. Insert the size of the PCB, quantity and color, then add to cart. I received the package after a few weeks. I ordered 5, but I got 7, that's cool. This is the PCB after soldering the components. So they are connected together with only 5 wires. They could be far away from each other using a long cable. Each circuit has its own 9-volt battery. So as you can see, each LED has its own switch. The flickering of the LEDs is because of the camera frame rate. I can't see any flickering with my eyes. But you can fix it by changing the frequency of this oscillator. Instead of using switches, you can use LDR light sensors. Now as you can see, it transfers the shadow of the objects to the LED matrix. That's so cool. You can change the light sensitivity by using this potentiometer. One of the applications of this project could be the local dimming that I made it in a previous video, but you have to use white LED instead of red. See what happened when I set this oscillator to very low frequency. By adding a big capacitor in here, you can see how it switches between the rows. But at high frequency, the human eyes cannot see that. This is how the CRT TV works. Please like this video and subscribe to my channel. Thanks for watching.